Hi everyone, and welcome to our last part of Activity 10. Today we're going to talk all about the rational root theorem. Now, in our previous lesson, we were given a bunch of examples of our polynomial functions that were in fact factorable that allowed us to find our zeros. But what happens if we do not have that ability? What the rational root theorem does is it narrows down the possible roots of a polynomial function to test. So again, we start this process by looking at all the factors of our constant term, call those the p, and then all the factors of the leading coefficient, and we call those the q's. And then we take the values positive and negative of all of the p's divided by q. This is what we test. Now, how do we test that? Well, we plug in each of those possible roots into our function for x and see if that output value is 0. Then yes, it is a function. Or we can use synthetic division to see if our remainder is 0, because then again, that also is going to tell us that that is indeed a 0 or a root of our function. So if we look at this first example, our constant term is p, our leading coefficient here is q. So we're going to take all the factors of p. So 1, 3, and 9, and again, we want the positives and the negatives, all the factors of q, and that's going to be 1 and 2, and then our actual values to test are going to be all of the p's divided by q. So 1 divided by 1, 1 divided by 2, 3 divided by 1 is 3, and then 3 divided by 2 is 3 halves, and then 9 divided by 1, and 9 divided by 2. So these are all of our possible roots. Now, how would we actually test which of these work to be our roots? So we would take our value, for instance, 1, and we would plug this in, 2 times 1 to the 4th power, plus 1 to the 3rd power, minus 19 times 1 squared, to the 3rd power, and then, again, minus 19 times 1 squared, minus 9 times 1, plus 9. And what we see is that our output value on this one is negative 16, which means this is not going to be a 0. However, if we test out negative 1, which I'm going to use the store button to help us go a little bit faster. So I'm going to store negative 1 as x, and then I have 2x to the 4th plus x to the 3rd minus 19x squared minus 9x plus 9. And when it stores negative 1 this time, we get that output value of 0, so that ends up being one of our zeros. And we can keep testing this for other values as well. For instance, if we did 3 as our x value, and again, this is what's nice about the store button, is you can kind of recall that real quick. We also see 3 works as a 0 this time. Check. We can also check negative 3. This works, if we recall, to also be a 0. And then we can check our last ones, like 9 and negative 9. If we store 9 as x, we see that this is not going to work out this time. Negative 9 also not working out. If we do this, so we would have to check our fractional values next, such as 1/2, which was one of our possibilities. And we find our final 0 this time with that on there. So again, f of 9 didn't equal 0, f of negative 9 didn't equal 0, but 1/2 did. So these were our 3 4 final zeros, -1, 3, -3, 1/2. Okay. Now there is another one for you to try over here. You have your P's and your Q's. First off, what would your possibilities be? And then after testing those, which ones end up working out to truly be your zeros, if any? Now, what we can see from this process is that things are kind of time consuming, and something that can help us narrow this down a little bit faster is using some synthetic division to help us store all these. So these are the exact same two problems that were on the previous page, right? Oops, not those two down here at the bottom, these two, right? These are the exact same problems. So we said on this page here that our possible zeros for this function were given to us here. Whoops, we lost some of them in translation here, but we have these zeros so far on here of 1. If we do our P's over our Q's, we had positive or -1, 3, 9, 1/2, 3/2, 9/2, right? And if we test out one we found out that works on the last page from testing, what we could do is we will put that 0 in the box, and then we take these leading coefficients from up above. So 2, 1, -19, -9, and 9. And we are going to perform some synthetic division. So the process is we bring the first term down, multiply this now by the number in the box, we get -2. Add these down, we get -1. This then gets multiplied by the number in the box, and that becomes +1. Add down, we get -18. This then gets multiplied by the number in the box. We get -18 times -1 is +18. Add down, we get +9. And then finally, 9 times -1 is -9. And we get 0 as our remainder. And again, this verifies that we have a 0 because that remainder ended up being 0. Now from here, we know that x plus 1 is a factor because -1 was a 0. And then these become the coefficients of our next terms. So 2x to the third minus x squared minus 18x plus 9. So notice this is 1 less than that degree was here. Now this is actually factorable, right? We could take out an x squared. We're left with 2x minus 1. Over here, we can take out a -9, and we are left with 2x minus 1. And so we have x squared minus 9 and 2x minus 1, along with that x plus 1 factor from the beginning there. So similar to the last lesson, now we have some factors that we can set equal to 0, -1, +3, -3, and 1/2 all end up being our zeros here. And again, that was a little bit nicer than having to plug in all of these zeros that we see here. Now, this is also going to be useful to us for this second type of question. Now, reminder, we had P and Q here. The factors of 5 divided by the factors of 1. So our rationals were just positive or -1 and 5. So we only had 4 to test there, right? And if we take 1 to test out like 1, again, we want these leading coefficients from this function up above, and we're going to synthetically divide. So bring down that 1. It gets multiplied by the number in the box. Add down, we have -3. This gets multiplied by that number in the box. add down, this becomes 5. Then we multiply this by the number in the box. So 5 times 1 is 5. And again, we see that remainder of 0 to confirm that that is a 0 for us. So x minus 1 is a factor. And then this time we would have x squared minus 3x plus 5. Now this at first looks like it might want to be factorable, but unfortunately there's nothing that multiplies to be 5 that then will add to be 3. So what we're going to have to use instead would be the quadratic formula. So we have a, b, c, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And what this allows us to do is find those imaginary solutions, because inside this we have negative 11 and then all divided by 2. And then in order to, again, take the square root of this negative, it would become I square root 11 on that. So officially this time, again, we have 3 zeros. X equals 1, and then 2 imaginaries that we otherwise would not have been able to get by just testing the P's and the Q's from the last page. You could not get those imaginaries otherwise. So these would be our solutions. All right, now, so this next piece is, again, a little bit more practice within synthetic division. This time they are telling you 4 is a 0 that works, and we now want to find all of the remaining zeros, real and imaginary. So bring down that first term, multiply these two, we get 4, add down to 7, multiply these two, we get 28, add down here, we end up with negative 8, we add those, and then multiply, we end up with the negative 32, which confirms that this was a factor. And our other factors then would be x squared plus 7x minus 8. Now this time, this is going to be factorable because positive 8 and negative 1 multiply to be negative 8, but add to be 7. So we have x minus 4 still, x plus 8, and x minus 1. So that our zeros this time are 4, negative 8, and 1. Right, that is definitely a lot nicer this time than having to test all of those rational roots themselves to see if they worked. All right, this last one is for you to try. First, you are going to perform the synthetic division, and then from there, find out what your remaining zeros are. Thanks everyone for watching. We'll definitely work more with the last of Activity 10 in class.